All right, so we have 4 different stations. Okay, over here, you are in the Con station. All right, so we've got our Con Academy over here that we've been working on for the MCA. You will have 20 minutes at each and every station before we rotate, which is why we have your bags over there. We have synthetic division over there. The way that that's set up, remember the other day I had you hop on to Ed Puzzle. Okay, in Ed Puzzle there are already 4 videos for you. Okay, 2 of them deal with synthetic division, 2 of them deal with long division. Okay, it says right on it which one is which. So if you're in the synthetic division section, that's what you're going to look at. You're going to watch that video, slow it down, pause it, do whatever you need to when you get to that station so that you understand the process. It's basically a little bit of a reminder for you, and then there's some examples on a sheet that you're going to work on. In this particular one, you're going to use polynomial long division. I know that basically you saw about 3 minutes of it in Algebra 2, and then you were told we're not using this, we're moving on. Here, we are going to be using it. So we have 2 videos that are assigned with that go through step by step, very detailed in the steps. You may want to slow the video down and pause it at certain points, because there are points where the gentleman is very fast. All right. The nice thing too is, if you're not quite getting it at one point, you can always rewind and get right back to where you need to be. Okay. Then in this section, we're dealing with the homework. We're going to go over the homework in here. Okay, it's a smaller group, so it's a little bit easier so I can answer the questions that you have. I'll be working up here with you. When done, my phone will make a nice little tone. You'll stand up, you'll rotate clockwise. You guys will go here, you will move to there, you will move to there, and then up to here. Questions on the process of what I'm asking you to do? Okay? While we are all together, I do want to point out one thing, because long division, you might need a little bit of a trigger. So I want to do one problem. I just want you to pay attention. I don't want you to do anything else. Okay? So, questions? Remember when we had this example on the quiz the other day? I to the 63rd. And we had to go through and we needed to make an adjustment to it so we could get this to be in its simplest form. And I had said, divide it by 4. How many times does it go in? Okay. Literally, we're doing this. All right, just again, to refresh our memory, because the process that we do here is the exact same one you'll do for long division. All right, when dividing, remember, 4 times what's going to get me close to 6? 1. Then I would take 1 times 4, and I would write it under here. What do I do with these 2? Subtract. Then I actually subtract. What do I do next? Bring down the 3. 4 times what will get me close to 23?
5.
Okay. 5 times 4 is?
20.
Then what do I do with that?
Subtract.
And I'm left with?
3.
All right. When you were little dudes and dudettes, you wrote R3. Okay? Means that there was a remainder of 3. Because when you were that little, you had no clue what the fractions were. Then we progressed and we moved to this. Right? Okay. Let's relate this to here. We talked about how whatever is left over will be our exponent. That's what's left over. What's I to the 3rd? Yeah, a little louder. Third.
-1.
Negative I. Okay. All right. So the reason that I wanted to just do this rather quickly was because when you're over there, this is the same process that you're doing. It's just it has X's, but it's the exact same thing. All right. That will help when all of us get to there to slow down, figure out what they're saying in there, and make the adjustments, because it's exactly the same process. All right. So you're at your different stations. Go ahead and get started. Okay. This group right here, going to take out our homework. We're going to go over it. When the bell rings, actually you won't hear my phone tone because we actually have the lunch bells right at 22 minutes. When the bell rings, like Pavlov's dog, get up, rotate to the next spot, get down to work again. All right? our points. So we have the x-intercept, and again, this is coming right out of the problem that was in the homework assignment. It will cross through the point -3, 0. It then crosses through -1, 0. And then it crosses again at, I believe it's 3, 0. You can double check, but I think those are the process. Then we also have the y-intercept. Okay, we see that one as 0, 2. All right. What we want to do is we want to come up with the equation that gives us this graph. So we have a couple different things. We know where it crosses the x-axis, and we know from Algebra 2 in the work that we did before that wherever it crosses the x-axis, we can get that to turn into factors. So right from the points, we know what x is. Then we can write that as, and I'm purposely leaving a space here, x plus 3 times x plus 1 times x minus 3. Remember seeing this before when we went from whatever the values were, the zeros were, we put them back in, okay? And again, I am leaving a purposeful space here. This is not like the quadratics we did before where we would put in, okay, well, we know what h is, we know what k is, we drop those in. We know what x is, we know what y is, we drop those in. And then we just have to solve for a. This is a little bit more complicated. So, I actually have to just multiply this out. Okay? For timing's sake, I know you know how to FOIL. So I'm just going to write down what it would be. Okay, you know how to FOIL. You've done FOIL many times. X times x is x squared, -3x plus x, and then 1 and -3. Now what?
You FOIL the x plus 3 into the x squared minus 2x minus 3.
So this has to be multiplied by everybody here. I'm going to do this just, I like to leave them so it's easier for me to line everything up. So literally x times all of that, x cubed minus 2x squared minus 3x. Okay, I just multiplied everybody by x. Now I'm going to multiply everybody by 3. So here, x squared is equal to -1. What's this going to give us? All right. So I'm going to have, when I square root, I'm going to end up with the square root of a -1. That's going to give me a complex number, right? I'm trying to find the x-intercept, so where it crosses the x-axis. If it's complex, it's not going to cross any of the axes. Exactly, yeah. If you do, that's great, and it's just a no at the end that you're not going to use it. But if you can already recognize it here, just stop. Okay, that's the whole plus minus piece. Now, again, another error is that we would forget to do the plus minus here. Okay, which then would leave me shy one of my x-intercepts. Okay with the process? How you doing? You look like you're a little foggy, a little lost, or you don't feel okay. All right, see ones. All right. So, again, I want to find out what the zeros are, and I want to find out, after we know what the zeros are, what the multiplicity is. All right. This first one, what is x going to be? -2, right? Because it's just the opposite of what we see. What is its multiplicity? That's not what I'm asking. What is the multiplicity? What's the number that is the multiplicity? Perfect. Yep, no, you're right. This is -2 minus. Okay, all right. Specific problems that we're going to make sure you're prepared to with, like the overarching issues. All right. Let's take a look right at 21. Start with 21. So, looking at all three of these terms, I want to try to see if there's something that I can take out of all three. Is there something I can factor out of all three? What is it? X. So now that we've figured out what we have to factor out, we divide every single term by x squared. All right? So when we divide, what do we do with our exponents? We subtract. All right? So then x to the 6th divided by x squared is x to the 4th. Minus the 2 stays. X squared divided into x to the 4th. X squared. And then when I divide -3 x squared by x squared, I'm just going to end up with -3. Okay, so double check, see if this is at least the same starting point that you were at. Okay. Remember in the last class we talked about how this looks like a quadratic, but it's not a quadratic. But it gives me the same kind of a graph, right? So if I look at this, this is double this, and there's no value here for the variable, then this is a quadratic type.